Good afternoon. Good to see you all here. We have a special guest speaker today who is one of ours, and I think many of you know Patrick. There's also information on the screens that it's been popping up today. We have a part of the gallery with some exhibit information, so if you haven't seen any of that, please take a look. Patrick is in a very special position within the college. He is the Department of Architecture for some years has had the Design Innovation Fellow position, which is a remarkable opportunity for us to bring in some of the best and brightest across the country who are focusing on innovative areas. So you're going to see how he expresses that today. He holds a BA in architecture from Clemson University. He later graduated from the University of Pennsylvania with a Master in Architecture, receiving the Cantor Trish Prize in Energy and Architecture Innovation, the Van Allen Traveling Fellowship, the Dales Fellowship, the Cone Fellowship, the Shank Woodman Merit Award, and upon graduating was awarded the Arthur Spade Brooke Memorial Silver Medal. So already kind of a nice track record. And today he's going to be sharing with us a topic that is based on his publication titled Machined Assemblies, Parts, Patches, and the Relations of Things. So please welcome Patrick Danahy.
Thanks again for the introduction. It's been a pleasure to be here the last, I guess, year and a half or almost 2 years now. This is some of the research that I've been doing in the last 2 years, but it also connects to a kind of larger body of research I've been developing since my graduate thesis and in recent publications in 2022. So this afternoon, I'll be presenting a body of work that extends one of my projects presented at the Traits Post-Digital Neo-Baroque Conference hosted by Marian Coletti, his research cluster, and the University of Innsbruck at their Obergurgel Research Retreat in late 2022. These conference proceedings established the third volume and forthcoming publication of interrogative research by Marian into the positioning of architecture in relation to both the digital and the Baroque. Marian suggests that post-digitality refers to a reinvention of the digital, not the absence of it, where the neo-modernist parametric tendencies of Patrick Schumacher or the early discrete movement of Gilles Retsin subside to accommodate complex interplays between physical and digital media. Counter to the call for reinvention implied by the term post in front of digital, the term neo seems to imply a continuation of the themes presented in the Baroque. These themes of the Baroque, which I will refer to later, have been primarily established by Heinrich Wölfflin in his text Renaissance and Baroque, where he lays out the differentiated models of each era, suggesting that the clarity of the Renaissance form gave way to vague and shifting representations of the Baroque. The post-digital era suggests digital tools give way to the emergence of design prostheses, where workflows are interrelating and complex, not bound by top-down systems of operation, but a bottom-up organization of matter through an assemblage of operative intelligences. A post-semantic architecture rejects the need for a turn towards symbolic reference, clarity, and reduction, coinciding with neo-Baroque and Baroque tendencies toward complexity and indetermination. Marcus Breitschmidt and Valerio Olgiati made a claim in early 2022 in their text Non-Referential Architecture that we live within a multifarious and variable world, one in which things are increasingly becoming more complex and indeterminate and therefore harder to generalize or describe. They expand this observation into a claim against referential design methods, but seem to actually be problematizing reductive forms of reference like iconography or symbolism, not referentiality itself. Where the first part of this claim emulates arguments made within the neo-Baroque movement, turning toward a necessary vagueness due to the increased complexity of things, the solution seems to be misplaced. Outlines for the differentiation between semantic and asemantic reference have already been established in texts like Vibrant Matter by Jane Bennett, Assemblage Theory by Manuel de Landa, Difference in Repetition by Gilles Deleuze and Felix Guattari, and Form and Object by Tristan Garcia, all of which are part of a larger body of work on metaphysics and being. I will be suggesting throughout this lecture that it is necessary for architecture to hold on to the familiarity of our referential material, but allow the symbolism and its semantic classifiers to subside. To establish this line of thinking, we can return to a historical timeline of architecture, representation, and surveying. The foundations of reference in architecture lie within our ability to document and translate existing media. This is first established in the surveying tools of our past. Starting with the Egyptians, who documented existing conditions with reference to lengths of body parts to redraw boundaries after annual floods, we can track the history of architectural representation from early surveying to more contemporary documentation methods. Critical surveying tools like the Groma and Chorobates, among others, allowed the ancient Romans to establish geometric order cast across the earth. These developments of surveying found success due largely in part to the geometric codification by Euclid, translating the arc and chord of surveying into abstract geometric principles. Euclid's theorization in optics of discrete conical projections that make up perception influenced figures like Vitruvius in his codification of three architectural representation types: ichnographia, plan; orthographia, elevation; and scenographia, often understood as linear perspective or section, a spatial representation. Later we see the formal invention of the measured linear perspective by Filippo Brunelleschi, which echoes the ideas presented by Euclid of discrete conical viewpoints and eventually allows the translation of spatial objects directly into drawn media. Following Brunelleschi's invention of perspective, Leon Battista Alberti and Albrecht Dürer developed linear perspective devices that translate Brunelleschi's observations into a tool for documentation and translation. Most significantly, the peak of referentiality occurs in not only the translation or documentation of existing works, but in the cataloging and analysis thereof. There are a number of works establishing stylistic or elemental catalogs of architecture that can be flattened and dissected through each item's difference. But one of the most notable is Sebastiano Serlio's La Architettura, which canonizes the classical orders. Heinrich Wölfflin extends these catalogs of architecture in his work Renaissance and Baroque, where he poses a psychoanalytical frame of differentiation between the Renaissance era and the Baroque. In doing so, he established 5 principles of differentiation: linear in the Renaissance versus painterly in the Baroque, planar versus recessional, closed versus open form, multiplicity versus unity, absolute versus relative clarity. Not only does this analysis lay the foundation of formalism in art and architecture, but it establishes methods for evaluation of architectural reference outside of cultural interpretation. Influenced by the work of Wölfflin and historic surveying methods, in 2016, Andrew Saunders developed a set of Baroque topologies using contemporary LiDAR scanning to document significant Baroque works in Piedmont and Rome. These scans extend the projection of light and line as a documentation apparatus and develop never-before-seen architectural representations of these churches. This work is a catalog of interior form seen from the exterior and develops a generative frame with which an architect may operate directly with the formal qualities, material conditions, or sculpted edges of the Baroque interiors. Andrew's Baroque collection is also an extension of historical works by Luigi Moretti, who cast interior voids as plaster molds or models to analyze the geometric relations of the interior form. 3D scanning allows for a near lossless data translation where qualities of material decay, weathering, color, geometric coordinates, and other data can be captured for documentation. However, these scans, like the casts of Luigi Moretti, produce a thin shell or manifold of which the edges wrap tightly, making it difficult for an observer to kind of enter into an understanding of the object. This thin shell deploys the ultimate poche, where only voided space and solid mass are considered. The results of the scan reveal the thin ontological border between them. It is through decomposition that we may begin to peel back the layered representations of 3D scans. Tristan Garcia in Form and Object states that, quote, being is a sense attributed to the relation between something and what contains something, or between something and what this something contains. This thinness of the 3D scan shell creates an ontological analogy to this thin shell of being. Garcia points to decomposition as a means to break this thin ontological shell, stating, quote, the idea of scientific, artistic, or social progress leads us to believe that one assimilates and realizes things by amassing them. We hope that a passage exists beyond the mountain of our objects, but it recedes as we approach it, since we accumulate at least as many layers of waste at our feet as we cross the distance to the desired goal. Objects accumulate through division and not merely through addition or multiplication. He likens this thin cast to the process of plaster casting, where the ontological identity of a thing is stuck between the void within the mold and its surface, where decomposing the elements of the solid shell begin to break the manifold of its identity. This principle of differentiation is also argued by Deleuze and Guattari within Difference and Repetition. If we turn again to history as our guide, we can look at the measured surveying works of Auguste Choisy. These works isolate architectural fragments suspended within their decontextualized orthographic planes. Their material, like that of 3D scanning, is captured and collapsed onto a plane with annotative marks and an assembly of divided parts. Through extraction, Choisy peels back the ontological shell of these fragments, allowing us to see the relations of part to whole and not just the totality of its architecture. These drawings, like 3D scan sets, document a depth of qualities through qualitative metrics, but unlike the thin shell of the scan, offer a speculation of the composition of parts and internal orders. Beginning the design stages of this project, a historical collection of 3D scans was used to establish feature sets and qualities to be directly extracted in the methods to follow. Operating through high-resolution advanced modeling workflows, one can directly, rather surgically, sculpt the surface and volume of these objects, where the registration of the individual identity is lost in service of a system of features cast across the objects, using macro scripting here to create systematized logics of translation, which can be deployed to produce this removal of individual identity. This establishes elements or features like the folded compound edges of the Baroque. Here we can see one of the results of this process of addition, subtraction, multiplication, and division, operating directly, not symbolically, and without the reduction necessary to produce generalized signs. The movement and gesture of this thing are built on familiarity and reference, yet its composition is novel and estranged. Its parts are differentiated, peeling back the thin shell of its form to suggest a mereology of internal relations. Miming the elemental extraction of architecture of the past, often focused on separation of stylistic fragments within larger ordering systems, this work decomposes the whole into a set of operable parts, allowing the viewer in. Through differentiation, we understand a thing. Deleuze, Bennett, Bogost, and many other scholars have made this argument, as did I in my graduate thesis work, operating through the quantification of design data through mathematical operations within the latent space of a generative adversarial network. The first of these decomposition methods is a quad-tree recursive subdivision based on the standard deviation of pixel parts. This method imports an external logic of division, echoing the algorithmic base for JPEG compression algorithms. Like the early developments of perspective, our new tools allow machine learning and algorithmic design to augment our own way of seeing. Photogrammetric scanning and image-based machine learning suggest that there is a direct translation between the multiple planes of image in space and the 3D form that follows. Using this logic in reverse, we can decompose the thing into its image sets, operate in 2D arrays, and cast them back like the early orthographic projections of Vitruvius. This understanding of geometric projection and architectural representation is best explained by Robin Evans in the projective cast. With quad-tree decomposition, we import an external logic to decompose our features or fragments. But with this second decomposition system, we use clustering algorithms and agent-based territorialization to read the edges present in the image and decompose it into its parts, developing boundaries directly related to the content present. Both decomposition methods are non-semantic, not labeled data, reading the quantitative metrics that translate to qualitative perceived features within the image. A potential third of these methods might be object detection or feature detection using models like YOLO trained on the COCO general dataset. This is just a type of model for object detection, which decomposes the image into clusters of pixels fitted within the classification of pre-existing datasets. However, within these models, you get a semantic classification that can, although sometimes be helpful in determining the qualities of a thing, can also bias the interpretation and lead to a reductive lens, where materials unknown to the model produce a strange classification. It is the vague and indeterminate qualities of things that produce a non-identity, which accepts a release of semantic definition or reference, privileging the qualities and relations of things over their reductive classifiers. Unknowing detaches us from our seat of assumption, developing an intimacy with things. From this point of unknowing, we can produce vague referential gestures without turning to assumptive symbolic reduction. Were I to ask everyone to draw a column, you are likely to draw some derivative of a classical Doric column, emulating a generalized reduction of the idea of a column. This avoids all of the column's actual properties and allowance for difference. Jane Bennett calls us, in Vibrant Matter, to let our assumptions subside, stating, quote, "We must develop a concept of non-identity to cure the hubris of conceptualization. Note that the discriminating man both subjects his conceptualizations to second-order reflection and pays close aesthetic attention to the object's qualitative moments, for these open a window onto non-identity." So, in this non-identity, or it is this non-identity, that casts aside the assumption of the general or the reference to a reductive sign and instead allows for perception of the thing's qualities themselves. A deeper and more vibrant understanding of things is what Bennett suggests. Here we can see an image of a facade. The image is seemingly whole, with its semantic clarity still intact. But if we looked closer, we would notice that a small tile at the bottom right has been removed and substituted with its closest perceptual match. This substitution establishes new relations of image parts, creating a discretized image space where each tile holds a relational weight, constructing an ecology of aesthetic parts. As more parts are removed, each remaining part is variably weighted and redistributed according to perceptual similarity. The goal of the system being to reduce the perceptual shift of the whole relative to the selected remaining parts. The edges of the parts are agnostic to the image edges, but this substitution reads the local edges within each part. This is a collaging which does not care about the rough constructed edge, and yet seeks to unify and coordinate relative to the paradigmatic position of parts. With further removal, the image appears to operate in a discrete space, but the rules are operating holistically, resulting in a flickering between composition or clarity of the whole and recognition of its parts. If we read images like machines, we become agnostic to the semantic references within them, instead reading clusters of pixels, patches, and parts. When the segmentation of an image does not correspond with its semantic edges, we sever the semantic reliance on or clarity, beginning a process of qualitative redefinition, a non-symbolic form of reference. As these severed parts scale relatively, their clarity fades, offering new interpretations. The edge of the pixels now reads as the part, offering a reveal of another level of discrete sample space, not impacting the machine's vision of the part, but shifting the human perception of it. As the relative resolution of the part scales down, we regain the semantic clarity of the image, drawing back the semantic edges onto the severed part. The machine is agnostic to this relative resolution and its semantic implications, which we can leverage to assist us in our construction of a non-symbolic or non-semantic qualitative reference. Machine learning acts to rapidly extract and synthesize data with options to embed semiotic positions or extra-relational classifiers into the systems. This type of operation replicates familiar forms of referential intelligence, maintaining a semantic positioning. Machined Assemblies proposes that through the layering of machine learning models with varied methods of seeing, operating with resolutions not relative to human perception, and the removal of fully connected semiotic classifiers, creates a semantic death that focuses design towards a qualitative analysis of the character of things. Leveraging the architecture of the Learn Perceptual Image Patch Similarity Model, we can make indexical comparisons between image structures, aligning color, edges, and other features at multiple scales through convolutional layers. This model is based on the SSIM measure, which is often used in machine learning models as the loss function because of its ability to determine image structure similarity. The LPIPS model adds convolutional layering to this metric, allowing perceptual similarity to be measured at low-level, mid-level, high-level, and high-level feature scales, and the correlations of these features or patches to be drawn across all permutations of relations. We can use this model to sort the severed parts based on feature similarity within an indexical space, constructing an ordering space outside of the semantic position. It is not enough to just destroy the legibility of the thing. Instead, we need to allow it to develop new relations, draw out new borders, and construct assemblies. The daisy chain metaphor Ian Bogos suggests in Alien Phenomenology is an operative tool where, quote, one metaphor clarifies a single relation, but when it becomes overloaded with the metaphor used to describe another relation, its clarity clouds, resulting in distortion and confusion. Operating through a perceptual similarity model, machined assemblies, a daisy chain metaphorical device operating in multidimensional arrays, opens opportunities for material scaling without semantic associations, where the syntagmatic relations are fixed and the paradigmatic parts allow for substitution. In discussing this daisy chain metaphor, Ian Bogos references Ben Marcus's text, Age of Wire and String. In this text, the semiotic clarity of the sentence breaks down as new relations are drawn out. If the brother is built from food, then how too can food be described like precipitation and have geographic specificity? What then is a brother? What then is food? If we look, as the machine does, toward images as syntagmatic and paradigmatic indexical arrays, we can operate like the sentences of Ben Marcus to draw new relations at various scales. Using existing methods of image compression, we can move beyond uniform tiles toward recursive variable subdivision of images based on standard deviation of image pixels. We can then substitute the contents of the image agnostic to the semantic reference of the original, instead finding the closest features to reconstitute the image whole. Here, the edges of parts hold and recede relative to the content present within them, drawing figured boundaries like the assemblages of DeLanda and Deleuze. The machine does not care about relative resolution, and therefore images with similar features may reveal their pixel composition and produce a vagueness of the foreground while still preserving the overall qualitative effect of the original composition. The model is multi-scalar, allowing the viewer to question the overall material scale of the thing. We can extend these methods to both 2.5D and 3D, discretizing 3D models and indexically substituting their parts based on axial viewing planes. Constructing a variably weighted ecology of parts, the manifolds of which can determine fabrication molds. Allowing the user to define a coordination or a coordinated relation between aesthetic effect and ecological efficiency. Where the edges bleed, new figures can be drawn to redefine the qualities of the original, not meant purely as discrete or collage, but a redrawn assemblage flickering between the aesthetic effect of the whole and a multi-scalar relational system of substitution. Starting with scans as a generative tool, we operate within direct reference to our thousands of years of architectural history. A familiarity in the gesture of things is preserved while the individuation of their identity subsides. It is not about their semantic clarity or registration, but about the direct use of features at high resolution to promote a near lossless form of reference, a non-semantic reference that avoids reduction. The evaluation metrics are held in the familiarity felt by the viewer, the folding of edges, and the movement of the geometry. It is not replication or reduction, but it is something estranged, defamiliarized, yet sympathetic. Its manifold is broken to parts, allowing the viewer in. Creating new ecologies of broken parts, reassembled into what David Leatherborough calls whole parts, whose edges flicker between registration and not. Each cluster gets its own character, decomposed by either an external logic of geometry cast upon it or a close reading of territorialization of its bounds. The figure is drawn or implied, constructed by the designer, algorithms, or the viewer. These objects exist in various stages of part to whole, in both unknowing and familiarity, a non-identity that preserves qualities without reductive generalizations. To return to our current position within a multifarious world, as suggested by Marion Coletti, Marcus Breitschmidt, and Valerio Olgiati, among others, We must question how we operate through reference today. Marcus and Valerio have suggested there must be non-referentiality, relying on form and material as both abstraction and solidity, or the material unification of its form. In this lecture, I hope to have landed an idea that it is not necessary to push all the way to non-referentiality or autonomy of our design outputs. To accommodate for our multifarious and differentiated world, we need only to turn to non-symbolic or non-semantic form of references, one that allows for non-identity, vague familiarities, and an unknowing of our own assumptions. Where the digital was clear, linear, and an extension of modernity's hope for autonomy of the discipline, the post-digital is interrelating, indeterminate, and complex, welcoming external referential material. Where the Baroque is concerned about the qualities within a composition, with the edges of figures fuzzy and difficult, so too are the edges of the Neo-Baroque, emulating the deterritorialization and difficult edge described by Danahy in assemblage theory. I'm happy to answer any questions and open it up to an extended discussion, but I would also like to welcome everyone over to the exhibition across the hall, and I'm happy to extend discussions in that space as well, so that we can kind of talk directly about the work and its relation to anything that I've said. The QR codes access augmented reality models of all of the parts in different versions of assembly, which can be scaled and placed by anyone, exchanging between physical and digital space, extending principles within post-digitality. For now, this only works on iPhones within the Apple Quick View app, but you only need to place the QR code in your camera view, and then you can access these models. So hopefully they can kind of exist throughout the campus or wherever you travel, and if you want to share via Instagram or whatever other platform where these things land, I think that's one of the exciting things about these kind of post-digital or digital physical overlays, is that we have an expanse now of external access to our digital tools. Thank you.